Hi, this is Kara Lee from Portland Community College, and this is another stats video for Math 243 on sampling methods. So let's look at example 1 here. A company packaging snack foods maintains quality control by selecting cases from each day's production and weighing the bags. Then they open some of the bags and inspect the contents. How can they choose the cases and bags in order to get a representative sample? A representative sample is one that matches the characteristics of the population. Okay, so this is a great example. We talked last time about the difference between the population and the sample, so let's review that to start with. I'm going to draw the circle. A big circle is the population. And a small circle for the sample. Okay, let's think about what these would be in this situation. Population is the entire group that we're looking at, and the sample is just the part that we're going to measure, just the cases and bags that we're going to measure. It does say they do this each day, selecting cases from each day's production. So that tells me the population is each day's production. We're looking at this day by day, so the population is today's production or tomorrow's production. The population is the snack foods. Oops, change my color. Population is the snack foods produced for the day. And the sample is the sample or subset or group. This is what we're going to talk about today, is how do we figure out what this sample is? So we need to get a sample select a sample or a subset of the day's production. Okay, and we want to get a representative sample. So let's talk about representative with the color green. So a representative sample You might be wondering, how big a sample do we need to get? A lot of people think, wow, we need to get a lot of information, so we need to sample a lot of these cases and bags, maybe almost all of them. Now the problem in this one for the company is once they open the bag to test it, they can't sell it anymore. So they have to be sure that they sample enough, yet not too little, but they don't want to waste or use too much of their product. Okay, so a great analogy for this is a stew. Let's say you're making a stew. Whoops, still working on learning this pen here. This is a big pot of stew, if you can't tell. Okay, you're making your stew and you go to taste it. Do you have to eat the whole batch of stew to know if it tastes good or not? No. You really only need one spoonful, right? Maybe a couple spoonfuls. The idea is you need to get a representative sample or a representative spoonful. So if I draw one spoonful, I really just need to make sure I get, it doesn't like me to draw small things. So I'll draw some little squares. I really just need to get a little bit of each thing in my stew. Maybe some of the broth, no E on broth, some of the broth, some, a pea, a carrot, a piece of beef or tofu or whatever you have in there. We just need one spoonful to taste it. So that's our idea, is to get one spoonful of our day's production, a representative sample. Okay, so this video is going to be all about different types of sampling. You can imagine this gets complicated. What if the production facility has more than one production line, more than one snack food, different sizes. They've got 3 shifts. They've got production going on over time. This particular example gets into statistical process control, which we won't do in Math 243, but it's a very, very interesting topic. Okay, so you might be thinking something along the lines of, we need to, if we're going to choose these cases and bags, we can't just go over and choose, let's just pick these 3 cases over here. Or let's go out at 2 o'clock every day and take one case off the line, or something. You might be thinking, how are we going to do that? You've probably heard of a random sample. We need to do some kind of randomness in order to get a representative sample, not just a sample that is convenient. Oh, this case is right here, but we don't know if that's representative of the entire production. Okay, so I want to talk a little bit about randomness before we get into the types of sampling. So let's scroll down here. Okay, in our class survey, you were asked to pick a number at random from the numbers 1, 2, 3, and 4. Let's say, okay, if you're picking a number at random, what would you expect the relative frequency to be of each number? Well, if it's random, then we would expect the numbers to come up the same amount of time, right? So we would expect them each to come up a quarter of the time, or 25%. If random, the frequency would be 25%, and that is the relative frequency. 25%. Okay, so that's why I did have this question on the survey, so we can check it out. So let's look at the class data and calculate the relative frequencies. Now, in this particular term, we're having snow and ice, so not everyone has finished the survey yet. So I'm going to go to a complete class, which is from last fall. And the content from D2L. Right now, you might only see class survey. When it's finished, I will put up class survey results. So this is actually from last term. And these are all, okay, it's in column F. These are all of the questions that were asked, and this is all anonymous data. This is the column, 33334, 332, 332, 333. I lost my place, but you can see, I don't see a lot of 1s or a lot of 4s, do you? Now, I have counted these numbers already, so I'm going to go back to the notes. And in this class, number 1 was not chosen at all. Number 2 was chosen by 5 students. 3 was chosen by 18 students. And 1 person chose 4. And there were, we know from the last video, there were 24 students. And so we're going to divide each of these. So 0 divided by 24 is a big 0%. 5 divided by 24 comes out to 0.208, or 20.8%, moving the decimal over 2 places. Oops, my percent looked like a 9 there. Okay, 18 is 75%. And 1 is 4.2. %. This is not close to random at all, is it? Not. This is 20%, but this is 0, and that's 4.2, and that's 75%. It turns out that people actually choose the number 3 way more often, about 75% of the time. This one was right on. Something about the pleasing nature of the curve of the 3 appeals to a lot of people. It's really, really interesting. So what's the point of all this? What do you notice about the frequencies? First of all, the selection was not random. Meaning each number was not equally likely to be chosen. Each number was not equally likely to be chosen. Very interesting. Okay, so what's the purpose of this is what we think is random, what we think we're doing that might be random, might not be random. We all have bias, things we're aware of and things we're not aware of, and we could be unconsciously choosing something that we think is random when it is not, in fact, random. So, let's write that down. I think that warrants a new color. Let's go back to orange. What we think is random may not be. Due to, some people call it implicit bias. Let's call it that. Explicit is what we're aware of, implicit, what we're not aware of. We may not be aware. Okay, so what that tells me is we need a different method. We need something that is actually random in order to get a representative sample. And not just going out, oh, I'm friends with Joe on the line and I'm going to sample from some of his production today. So let's go to the next page. We are actually going to use a random number generator. You may have done this before on calculators or on Excel. Let me scroll up. Okay, great. So choosing a random sample using a random number generator. And here's another example. A scientist is studying the river flow of the upper Iowa River. In doing so, she's measuring the rate of flow at various catchments, which is where the water feeds into the river. She numbers the catchments 1 through 76 and decides to randomly sample 10 of them. Use a random number generator to choose a random sample of 10 catchments. Okay, so for this, really good resource is random.org. So I'm going to go there. You're welcome to go there yourself if you like. Oh, one thing real quick, I was going to just show you what we have of our survey so far this term. Here's the bluest one. 2 and 3 are actually even at 40%, and nobody's picked 4 so far. So I thought it might be useful to see more than one class. See if this really holds up. And let's look at the, this one's the 9 a.m. class. Not everyone's responded yet, but wow, here's the 3, 63%, and these are the 4s and the 2s. So, very interesting. Okay, here's random.org, and this is really interesting to read this first paragraph talking about true random numbers versus pseudo-random numbers. If it's coming from a calculator or Excel, those are called pseudo-random because they are generated by a formula. So they could be reproduced. But random is, they're selecting something, they're saying the randomness comes from atmospheric noise, and so they're picking from something that is random in order to generate the random numbers. So there are lots of things on this website, including lottery quick pick. So not advocating that, but you can certainly use it. Games and lotteries, random drawings, we want an integer generator. So we want whole numbers, in other words, integers. And we can use this, generate blank random numbers. Each integer should have a value between 1 and 100 and format in 5 columns. So let me go back to the notes for a second. We need to figure out what we want to put in here. She numbers the catchments 1 through 76. So let's get from 1 to 76. The number of columns is not really important. It's just for making it easier for your eye to read. Generate blank random integers. So we need a random sample of 10 catchments. Now we're going to be choosing 10, but we do need to make this number larger than 10. And you'll see why more clearly. So I'm just going to pick 100 for a round number. And let's go back to random.org and go ahead and do that. 100 between 1 and 76. And 5 columns, and it says get numbers. And that's what our random numbers look like. It's got a timestamp so you can see when they were done. It also says the numbers are generated left to right across columns. So they're actually going this way from left to right and then down to the second row, which you could probably consider it random either way, but this is the way that they were generated. Okay, now back to the notes packet. I have a set of 100 random integers. It looks like I did 1, 2, 3, 4, 5, 6, 7, 8, 10 columns to fit on the page better. But I want us to all use the same numbers so that we can get the same answer for the sake of learning. Using these random numbers, we want to select a sample of 10 of the river catchments. So she's numbered them, but when she's doing her sample, she wouldn't want to unconsciously choose a certain catchments of a certain size or ease of getting to, or anything that you might be unaware of. So we're going to use these first 10 numbers if we can. So the first one would be 38. The second one would be 75. The third one would be 14. The fourth one would be 24. The fifth one would be 49. The sixth one would be 75. Now that's a problem though, because we've already looked at 75. 75 is already part of the sample. So this happens a lot because the numbers are being generated randomly. They will repeat. So we're going to skip that one. Let me just start that over. Repeat. Okay, so now we need to check if we've seen these before. 53, that's good. 61, okay. 14, okay, we've already had 14, so that's another repeat. Sorry about that. Okay, hopefully this will get easier over time as I go. Okay, so 14 was a repeat. The next one is 52. We don't have that one yet. And I think we need 2 more, right? Because we skipped 2 of them. 29. Is that okay? Yep. And 58. Is that okay? Yes. So 29, 58. So that is a random sample of 10 catchments. Some people use the random number generators on Excel or calculators, and that's generally regarded to be random also, but this is a really wonderful website to use. Okay, so now that we've talked about randomness and the importance of randomness, let's talk about different types of sampling. So, especially in complicated situations like the cases and the bags, you can imagine different ways of doing the sampling. And so there are several different types of sampling methods. So let's go to the next page. Sampling methods, the good ones. So there's good ways and bad ways to do this. Now for the sampling methods, there are 1, 2, 3, 4, 5, 6. 6 different ways. So let's talk about each of these. Okay, census. You've probably heard of census before because the U.S. does a census every 10 years. That's where they sample the entire population. Sample the entire population. You might think that's not correct because a sample is different than the population. In the census, I guess they're the same. You're asking the entire population. And I want to do an example for each one of these using PCC students as the population for each type of sampling. So this would mean we need to survey or ask or count, whatever we're doing, measure every student. Every single student. Okay, simple random sample, also called SRS for short. SRS. Simple random sample is actually what we just did with the catchments. That is, individuals or streams, whoever the subjects are chosen at random. I'll say subjects just to make it a little more broad, because it could be bags of chips. Chosen at random. And so, in other words, each subject is equally likely to be chosen. All right, let's think about how we could do that at PCC. How could we take all of the PCC students and then somehow use a random number generator to choose a sample of students? Well, one thing that's useful is an identifier. Identifier variable. We have G numbers. So we could select a certain number of G numbers. Select random G numbers, right? We could go to random.org. I think they're 8 digits, so we would start with whatever the 8-digit number is and go up to, so it'd be like 1 and 7 zeros. Whoops. I didn't put my comma in the right place. That would be the smallest 8-digit number we could get. And then the biggest would be 99. I don't know if anyone has this G number or not. 999999999. Now, an interesting thing is staff and faculty have G numbers also. I have a G number. So not all these G numbers belong to students. So we would have to get the sample, then see if it's a student. Get the next one, see if it's a student. If we're looking for sampling students, which we are in this example. Okay, that is a simple random sample. Each student is equally likely to be chosen. That is a great method, but it might not fit for every single situation that we're looking for. So let's just say we're sampling, and just because it's random, just by chance, we get more students from Rock Creek in the sample. Would that still be a representative sample? You know, this is kind of like going back to the stew example. This is like you just blindly, you turn away and you just blindly put your spoon in the stew, and whatever you get out is what you get out. You didn't try to get a pea and a carrot and a piece of tofu or a a piece of kale, whatever's in your yummy stew. So that's why we need some other methods too. Stratified is the next one. And strata, think of strata as layers. Okay, there's different ways that we could stratify our population at PCC. One way is by campus. I was just using that example. What if we broke things down into campus? Southeast, Cascade, Sylvania, and Rock Creek. And then we choose some at random from there. Now I'm making different numbers of dots. There's different ways you can do this even. We could choose an equal number from each campus. That would be representing each campus the same. Or, because not every campus is the same size, in fact Southeast is much smaller than Sylvania, we could choose proportionally number of students from each campus, say the percentage of the population at each campus. We choose that same percentage of our sample. So this could be equal. Actually, before I go there, let's say what stratified is first. We want to separate into groups. Then we are going to choose randomly from each group. So take a simple random sample from each group. And then what I was going to say is it could be equal size or proportional to the group. Group size. Could be equal size or proportional to the size of the group. For example, that's why I made 2 dots for Southeast, 3 dots for Cascade, 6 dots for Sylvania, and 4 dots for Rock Creek. That's just approximate in my mind. I don't know the exact ratio of the campuses. Okay, so that, for example, that is a great example for a PCC example. Divide by campus. Divide and select by campus. But that's not the only way to do it. We could also, what else could we divide by? How about number of credits? Right? Let's say we do a simple random sample, but we just coincidentally get a bunch of people who are just ready to transfer. And would that be representative of our whole PCC population? Maybe, maybe not. What about credit or versus non-credit? What about online versus face-to-face classes? So there are many, many different ways to stratify. So think of stratifying as layers, strata, or groups. Okay, systematic is another one. Systematic is where you can think of the word system. In that, you're going to sample one individual and then every nth individual after that. So sample every nth individual. So let's say over here for an example, I'm going to make dots for people 2, 3, 4, 5, 6, 7, 8. Let's say we sample every 8th person. So for this you have to either have a list, or maybe this is the cafeteria and you're going to ask. They want to just ask every 8th person randomly, congratulations, you're the 8th person. Will you answer our survey? Sample every 8th individual. Okay, so an example of that. Let's use the cafeteria example. Oops. 8th person. Just have to think about, will this be representative? This kind of works for the chip example. You could have some way to measure every 100th box. Pull every 100th box and then pick every 3rd chip bag in the box or something like that. So this is a systematic way. You could also have an alphabetical list, and you go along and you choose. So let's write that one down too. A different color. Alphabetical list. And you select every 100th person. Now, I'd probably suggest having a random starting point and then taking every 100 after that. So let's put that in parentheses. You could use a random starting point. Especially if this was something that was going to be repeated. If you were going to measure the snack foods every day, you probably wouldn't want to do the 100th one every day starting at the first one of the day, because there might be something going on where you're doing it the same way every time. So maybe you choose a random starting point. Maybe you choose a random starting point and then every 100 to 200th box or bag every time. So there's lots of different ways to randomize this. Random starting point. Okay. Now there's 2 more on this page. Cluster can get confused with stratified sometimes, so be sure you draw these pictures because I think they really help. Cluster is also subgroups, but I'm going to draw the subgroups into boxes this time. Okay, I'm going to number them. So with a cluster, you're also using subgroups, just like stratified. But the difference is we are going to randomly select an entire cluster and survey sample the entire group of that cluster. So a good example of this are classes or CRNs. So choose, let's say, 10 random CRNs. And then survey everyone in those classes. Okay, so let's go back to the definition here. So we're still separating into subgroups. I want to see what I wrote for this. Separate into groups. So we're still separating into groups, but this time actually, let me write that those are clusters. This time we randomly select clusters. And sample the entire group. Okay, this time we randomly select the cluster. So let's just say we're going to choose 2. And we randomly, I didn't do it randomly, but we randomly selected, went to random.org, and came out with 1 and 6. Okay, so that's the difference between stratified and cluster. Stratified, we are dividing into groups, but we're going to take a random sample of each group. Here, we're taking a random sample of the clusters, choosing two random classes, and then we're surveying everyone. So maybe I'll shade in. We're going to sample everyone in that cluster. These folks will not get surveyed at all. Okay, the last one on this page is multistage, which is not a new method in itself, but it's a combination, as you might be able to tell from multistage. It's a combination of any of the above methods. Combination of any of the above methods. Now, cluster and stratified almost seem like a multistage already. You're separating into groups and you're taking a simple random sample, but that is considered one method of stratified. And same with cluster, you are selecting a random number of, or selecting groups at random and surveying everyone in those groups. That is all part of the cluster method. Okay, so let's think about a way this might happen at PCC. Well, let's say we stratify by campus. So let's say 1. Stratify Wait, would that be an E or an I? That would be an I. Stratify by campus. Then what if we did a cluster and chose random CRNs at each campus? Choose, what do you think is a good number? 5 CRNs at each campus. Now this would be equal representation. That all depends on the context, like we talked about before. What's the purpose of the study? Choose 5 CRNs at each campus, and then sample all those students. So that would be a combination of stratification and cluster. Survey all students in those classes. Okay, so let's make a note. That would be, well, I guess I already wrote, it would be stratification, stratified, and then this part is a cluster. So that multistage is a combination of stratified and cluster sampling. Okay, so our whole goal is to get a representative sample for whatever we are trying to do. Let's go to the last page. Sampling methods, the bad and the biased. Okay, so if a sample is not representative, we say it's biased. So biased means not representative. Now, we don't usually do this on purpose, but it happens, and we want to try to reduce bias as much as possible. A bias is, here's the definition, any systematic failure of a sampling method to represent the population. A sample is biased if it does not represent the true population. There is no way to fix biased data, so it's better to design a good survey to begin with. Okay, a good example about this is the failure of the polls in the 2016 election. All the polls were off, so somehow the selection, the methodology was not purposely, but was biased. It did not represent the true population of people that actually went to vote. Okay, so here we've got, let's look at the overview first. 1, 2, okay, good. So we've got 2 of these, and then we've got some examples to try. The first of the bad and the biased is voluntary or self-selected sampling. People who respond to a survey or go online to write reviews tend to feel very strongly about the thing that they're responding to. So you can get more extreme opinions or viewpoints. Go back to orange. So voluntary means people choose whether to respond or not. It's also called self-selected. If I choose to respond, I'm self-selecting myself. Or if we go get volunteers, they're going to self-select. Okay, an example of this is something like Yelp, online reviews, An email survey that is just sent out once and only people who want to respond. There are ways to use an email survey effectively. And I'm not saying that you can't get good information from this or information from it, but what I am saying is it does not necessarily reflect the entire population. And so we couldn't say, well, 12% of the people who responded said this, and therefore 12% of the population would say that. We can't say that. But, you know, when you go on and read reviews or read Rate My Professor, that's another voluntary source of information. You can get useful information from it. You also have to take it with a grain of salt. Okay, convenience sampling is a little bit different. It could be voluntary. Say, hey, do you want to join my survey? It's choosing people in a way that's convenient for the researcher. And I'm saying people, but it's any kind of subject. It could be car parts or chips. Choosing people in a convenient way. For the researcher. Not for the respondents. Okay, so this could be just stand in the Great Hall. Probably should have been capitalized. What else is easy? Oh, I'm just going to survey my class. And then say that's representative of the entire PCC population. Nothing wrong with surveying my class if maybe that's my population or that's the information I want. But towards later in the term, we're going to be trying to infer from getting our sample to saying what can we infer about the larger population from this information. And so we would not be able to do it for that. Another thing that can affect things are incentives. Sometimes you'll see incentives. Incentives can be useful and motivate people to participate, but we also need to be careful that they are not biasing the results, like, oh, I'm going to participate because of the money, and someone else is not going to care that much, so that, you know, they're not going to participate. So we still want to have a representative sample. So, as you can see, there's a lot of things to be aware of when you're choosing a sample. Great. Okay, let's go down. The very last part of this is another example, and I'm going to have you try it. So you're going to get the most out of this if you pause this video and try all of these. It says, for each scenario, identify the type of sample used and a potential bias. Okay, so all the types of sampling on page 3, Census, simple random sample, stratified, systematic, cluster, and multistage. Also could be voluntary or convenience. And then a potential bias. So if you can think of something wrong or some way that that sample might not represent the population, and write that down also. Okay, so I'm going to pause the video and write these in, and you write yours in, and then start the video again.